Hey guys, I'm Caitlin. I'm part of ACM Hack, and in this workshop, I'll be introducing you guys to version control, specifically with Git. If you guys have any questions, you feel free to reach out to me or any other Hack officer or mentor in the ACM Hack Discord. So here's the links to the slides if you would like to follow along. And so let's start with, what is Git? Git is an open source distributed version control software. And you're like, oh my God, what does that even mean, Caitlin? And don't worry, guys, I will explain. So specifically, let's start talking about video games, specifically save points. And what a save point allows you to do is save all the progress you've made so far in a video game. You can basically save the current state of your game. And somewhere down the line, say you make a mistake. Because you have a save point, you can go back to the state your game was in when you saved it. And from there, you can start replaying the game and correct your initial mistake. So now you're like, okay, I get the save points, but what does this have to do with Git? Well, save points are to video games as Git is to program development. And if you've never seen this kind of logical analogy before, you've clearly lived a blessed childhood, I envy you. But what this means is that Git is the save points of program development. With Git, you can essentially save snapshots of the state of all your files. And what do I mean by state? I mean, what files are in your project folder and what does the code look like in all of your files? And with this, you can go back at a later time and refer to these snapshots to see what has changed between then and now, or you can revert your program to that previous state. This is different from just saving your file, because saving your file only tracks the latest version of that file. Once you save, previous saved versions of the file disappear and are no longer accessible. So let's talk about why we need Git. And we'll go back to the video game analogy. Imagine you're zipping through a game and you're having a great time, and no, you're not going to use save points because that's for noobs, and then boom, you made an oopsie. You died. Woo, game over. And would you look at that? You didn't have a save point, so you have to start all over again. Sucks, right? Same thing happens for your code. You can YOLO it and do things and yeah, it'll work, but I guarantee the larger the project, the more intense the coding is, the higher chance something will be messed up, and it'll be a major or minor, and you'll have a minor aneurysm trying to figure out what went wrong. And your Control Z button's just gonna get a workout, everything's on fire, your brain shuts down, and you stare at 150 lines of error messages that weren't there 15 minutes ago. So just please use Git. You don't want your code to go game over, and it'll make programming your project much easier, and you won't have to restart if some issue happens. So we've talked what is Git and why is Git. Let's talk about how is Git, or how to install Git. Git is a command line tool accessed through the terminal. So that means we have to install it in the terminal. For Windows users, that would be like PowerShell or command prompt. So for Linux, just in your terminal, you type in sudo apt-get install git-all, and you don't have to worry about this $sign right here. This $sign just means that this command is supposed to go in the command line. For Windows, good luck. Your installation is a little trickier. You gotta follow the slides. I've linked the slides again right here. And you gotta like follow this link to the direct installation website that I've linked, and then it's gonna give you direct instructions on what to do, and you're just gonna follow that. For Mac, you type in these two commands, once again without the $sign, all in one line, if you please. So it's like /bin/bash, like whatever, and then after you click enter, that loads for a hot second, then you do brew install git, and then that loads for a hot second, and then you've got Git on your device. Ooh. So Git configuration. You kind of got to configure Git so that it knows stuff about you. And this is important because if you're working in like a project with other people, Git needs to list information about you, so like people know who made the change and who to contact if they have questions about the change. And yeah, so it's important if you're working in a repository with a bunch of people. And what's a repository, often called a repo? It's a fancy name for the collection of all files in your folder that Git will be tracking. And by tracking, I mean paying attention to, recording the history of. And yeah, so we're just gonna set the name and the email you will be using with git config -- global user.name, and then you put your name in there, and then you can do the same thing with user.email and your email. So let's talk about opening the terminal, installing Git, and Git configuration. So y'all need to go to whatever is your Finder, and you're gonna type in terminal. It should pop up for you. It should be like, maybe it's called command prompt or PowerShell for Windows, but it should pop up under terminal. And now I've got my terminal opened. I'm going to zoom in because this is tiny. And then, so if I were on a Linux computer, to install Git, I'd do sudo apt get install git-all, just like that. But I'm not on a Linux computer, I'm on Mac, and this would be illegal. This is absolutely illegal. Oopsie. Oh, sorry guys. So that's absolutely illegal. I have to do the /bin/bash-c. It's a long freaking thing. So just copy it from the slides. And then the yeah, just copy this thing, and then you do the brew install Git. I've already installed Git, so I'm not going to actually run these commands, but now you know, kind of just got to type in the commands. And then Windows, y'all got to do something different. Good luck. I can't exactly follow those. And I've already configured Git on my computer, but if I wanted to set my name for the first time, I'd do git config -- global user.name Caitlin Q. Yeah, and then that just set up my name, and then email is email@gmail.com. Yeah. So let's talk about what saving looks like. Conceptually, imagine this whole set of save points you make to exist like this diagram down here. Each circle represents a save point, a snapshot of the state of your files were in when you saved, and each circle points to the previous one. So E to D, D to C, etc., etc. And in this way, snapshot E directly follows snapshot D and so on, which means that Git is allowing us to create a timeline of the evolution of our program, with snapshot A as the first save point of our project and snapshot E as the last snapshot. So how do we go from the files on our computer to the timeline of save points that I showed on the last slide? I'm so glad you asked. Now introducing the Git Workflow. Wow, I genuinely sound like a telemarketer. Sorry, guys. The Git Workflow has 3 stages. The working directory, which is the files on your personal device, the staging area, which has all of the changes that you want to make a snapshot of, and then the repository, which is the collection of snapshots, aka this diagram from the last slide. Let's break them down. So the working directory, once again, it's all of the files on your computer. So how do we introduce Git to the project files on our local device? You use Git Init, which creates an empty Git repository in the folder you're currently working in. So what does that mean? It means that Git has begun tracking what happens in the folder it is in, but because it's not been told to save anything, it's an empty timeline. It's like save point slots that have no save points in them. And this current folder that you're in, that you just called Git Init in, that folder should be the folder you put all of your project files in. So this folder is your working directory. So the next part of the workflow is the staging area. What is that? It holds all of the changes you made to your files that you want Git to include in the next save point of your program. So the staging area tells Git to pay attention to the files that are already included in there. So how do we get things into the staging area from the working directory? You use this nice command right here, git add, and then you pass in some files or like folders that you've changed that you want Git to pay attention to. Or if you want to put everything in the staging area, you just do git add dot, git add period. We're not going to go into how exactly that works, just know that it works. And you can just add everything in one fell swoop into the staging area if you do that command. Okay, but even though we've put our files into the staging area, we still haven't created a snapshot yet. You've just put everything that needs to be put in the snapshot in one place. So let's talk about the repository, the collection of all snapshots of the project. If they're placed into These snapshots are placed into a timeline so we can easily track how the program has changed over time. But what specifically are these snapshots? And we can answer these with the knowledge we just covered. These snapshots are everything that was in the staging area, just bundled up into a wrapper and displayed as one cohesive object. So how do we go from staging area to repository? We have this fancy schmancy command, git commit, and that'll just package everything up in the staging area into a commit and put that commit in the repo. And commit is actually the technical term for snapshot. I'm going to be using those like interchangeably throughout this workshop. Oopsie. And it's actually good practice to include a commit message. And you do that with git commit -m, and then in quotation marks, you put in your commit message. Because you do this because commits store who changed what with this, like who changed what in the files, but this kind of useless information without knowing why that person made the change. And so the commit message answers why, the why for each change made. Some extra git commands that might come in handy: git status. This displays the changes that you have made to your file since your last commit. It'll also tell you whether you have staged these files or not. Git Log allows you to see the list of commits in a repo. And so remember this nice diagram that I revived from a few slides ago? Git Log will basically list this diagram out in as a text version. So it'll say who committed for commit E, when they committed, and the commit message, which is important, which is why it's important to include the commit message, so people know what the commit does and they can track how the program evolved over time. Some extra git commands that are important because everyone makes mistakes, and like sometimes you got to go back and like to the previous save point /snapshot /commit. And you can do this with Git Restore. So Git Restore file undoes the changes you've applied to the working directory until it matches the state it was in when you last committed. And then Git Restore --staged files /folder that removes the files that you list from the staging area. So let's do another mini demo. We're going to create a project folder, and then we're going to create a Git repo in that folder, and then we're going to create a commit. So I'm going to go into my desktop, into a folder. Let's see. I want to create my I'm going to create my project folder in here. So I'm going to call it git demo, right? So like just put your project folder wherever you want. This is just specific to me. And then in terminal, we're gonna, you gotta get into the folder you just created. So we're gonna use the bash command cd. CD means change directory, and you can either move incrementally through folders or you can just change your path completely. So first, I kind of want to know where I am for terminal. I'm going to do ls because this lists all the folders in the folder you're currently in. And I know that my folder is on the desktop somewhere. So I'm going to do cd desktop, and then you keep like lsing and cding until you get into your project folder. However, I already know the path to get to my folder, so I'm just gonna change my path. So from desktop, I'm gonna go into my nest of folders. Okay, so see, right here it says git demo. That means this is the folder I'm currently in. And so I want to make sure this folder is empty. I'm going to do ls-a. So ls earlier just lists, we saw that it lists all of the folders and the files that are in the folder we're currently in. ls-a lists all folders and files, including hidden ones. So we see here we have two folders, dot and dot dot. We're going to ignore these. You don't really need to know about them. They just point to this folder and the parent folder, which is like the folder we were in before we entered this folder. And you don't have to know much about them right now. So I want to create a Git repo, right? So in this folder, that's going to be my project folder, I'm going to do Git Init. And we see it initialized an empty Git repository in my folder. So if I do ls-a now, because Git doesn't show up, the Git repo doesn't show up if you just do ls, so you have to do ls-a. We see the new .git folder in there. Okay, so we're all ready to make changes, and I'm gonna create a commit now by creating a text file. So inside Git demo, I'm going to create a file using a text editor, like a code editor IDE. You guys can use Xcode, Atom, like VS Code, whatever you want. I'm personally going to use Visual Studio Code. Oh, please load. Thank you. Okay, so this Visual Studio Code, I'm going to open this Git demo folder over here. So I gotta go through my desktop. This is basically the same path you have to follow to get your terminal in the correct place. So I'm just gonna get into the Git demo folder. I'm gonna open that. And we see that this is an empty this is an empty folder, so I'm going to create a folder called create a file called philosophy.txt. Right. And so I need to put something in there. I'm going to write, we're all in a yellow submarine. Save that. Cool. We have a text file now. So if we do ls, we see that we now have the philosophy.txt file in there. And if we do git status to see what has changed since we created the repository, we see that we have a file philosophy.txt. Nothing is added to the commit, and this philosophy.txt is an untracked file. So I want to add this to the commit. So first I got to put it in the staging area. So git add. If I had multiple files in here, I would do git add period, but alas, I do not. So I'm just going to show you what it's like to just put in the file name philosophy.txt. So if we do git status now, we see that there are no commits yet, and the changes to be committed, meaning this file is in the staging area. We have philosophy.txt. And if you wanted to unstage it, you could do git rm --cache, and then philosophy.txt in this for this file right here to get this out of the staging area. If you decide you don't want to commit it. So let's do git commit -n, and we're going to say create philosophy.txt and talk about submarines. For commit messages, try to make them succinct, but like informative, not like this, because I don't really have much to say about this commit. Like when you're writing about code, say like what file you changed and why you changed it, like what bug were you fixing, what functionality were you adding. Yeah, because that's good coding practice. So I committed, and I want to make sure that this commit actually went through, like it was added to my repo. So I'm going to do Git Log to check to see that my commit went through. We can see that it did indeed go through. This is the commit. We have the author, my email. Please don't spam me. We have the date I committed, and then my commit message. So this is why it's important to have good commit messages. Otherwise, when you're looking back, you're not going to understand why you made that commit. Like, what did you change there, and like why? Okie dokie. Let's go back here. So I've mentioned like you can work on with other people in in repositories, and you can have collaborators for repositories, but I've not mentioned how we're gonna do that. Like how do we get multiple people working on different devices to see and edit the same project code? Because like with every multiplayer game out there, we need a server or some space on the internet with which we can see what other people are doing, interact with the progress, interact with the progress they're making to help us finish our game. So how are we going to do it? Google Drive? Nah, we're going to use GitHub. And what's GitHub, you ask? It's a Git-based version control system that is like in the cloud. It's essentially an online repository that you can use to further save your commit history or the history of snapshots you've made. And you can use it to share code among multiple people because it's easy to download the online repo's code, create commits on your downloaded version, and then submit these changes to the online repo. And another name for the GitHub repository that I'll be using is the remote repository, and I will be using the word remote a lot in this workshop, so just know what it means. And let me emphasize very emphatically that Git is not the same as GitHub. GitHub is the cloud version of the repository that everyone can see and download and do whatever with, and Git is the version control system on your device. So practically, we'll be using Git locally and using GitHub to receive and send code amongst our fellow workers. So how does Git and GitHub interrelate? What does using GitHub look like? So each computer in GitHub have their individual copies of the repo, and as a result, the project code. We call the version on GitHub master version or the remote repository, and all versions of the code on personal devices are local copies. So we can download the local copies of the code. We can download local copies of the code onto our own computers from the master version. And after making changes, we can submit these changes. We can apply these changes to the master version. So why do we have this like indirection, I guess? Why do we have this like levels of complexity? Like, why can't we just have shared code like a Google Doc or something? Well, it's mainly for safety. Let me like illustrate this with a shared coding space. So say that everyone shares the singular coding space like a Google Doc, and you, who is very smart, and your friend who is unfortunately not so smart, are editing the code in the same shared file in what looks like C of all programming languages, unfortunately. And say your friend adds some buggy code to the shared code file, and kaboom, everyone's version of the project just stops working. Because you guys did not have separate copies of the file, once one person inserts buggy code, the code just stops working for everyone, it explodes for everyone, boo, and game over, because now no one has a working version of the project. However, if everyone has separate copies of the code, one local version can submit non-buggy code to the master version, which everyone can see and download. Yeah, and then the master version updates, and then the master version is downloaded by another person, and that person adds in some buggy code, and because we have separate copies, only their version of the project, blows up. And if that person who messed up their code has no clue what went wrong, they can just re-download the code from master copy in GitHub and try again. So essentially, separate copies create further safety nets for everyone in the collaboration process. So how do I get my code from my laptop onto GitHub? So everyone has to set up a GitHub account. You can follow this link right here. They're going to ask you for an email. I suggest you use the same email you used earlier when configuring Git on your personal device. And then one brave, enthusiastic soul among you is going to follow this link, https://github.com/new, and you're going to create a repository, a new GitHub repository. You're going to make sure that it's public. And then on your device, like earlier when I was demoing, you're going to create a folder on your device, and then you're going to create a Git repo in that folder with Git Init, and then you're going to have to create a commit by like adding a file or something, changing the state of the folder. And then once you create that commit in your terminal, you got to type in these 3 commands: git remote, add origin, and then you're going to get a GitHub repo URL when you create this GitHub project. So don't worry about finding it. You'll definitely know it when you see it. And then you're going to type in git branch -M. Capitalization is actually quite important in terminal, so make sure that you capitalize this. Capital M main, and then git push -U origin main. We'll be going over these commands in purple in a bit, but basically what this does is it binds the GitHub repo you just created online on GitHub to the one you created locally. And now you can get the code in the GitHub repository onto your device, and you can submit your local repository and its changes to the remote repository. And now the GitHub repo will have the commit you just created on your device rather than being an empty repository. It's neat, right? So in order for everyone else to get that online repository, you have to use the command git clone. And then you're going to use the same GitHub repo URL that we used in the last slide. And this basically gets a copy of the online repo onto your local device, and it'll bind that local repo to the online repo so that it copies the commits from the GitHub repo specified through the URL on your device, and then you can work on that local copy and then submit your changes to the online repo. So it's like easy collaboration. So how do we get our code to GitHub? You got to use this special command called Git Push. And I mentioned this command 2 slides earlier when talking about linking the remote repo to your local repo. And I said I'd go over it later, but well, later is now, so let's jump into it. Um, so remember in the previous like illustration slide when I was like, oh yeah, you can send your code to the remote repository. Basically, you're using Git Push to do it. Git Push essentially compares your local repo to the one on GitHub, and if your repo has something the GitHub one does not have, it copies your changes to the online repo so that other people can get the most updated version of the code. And I have this hand-drawn illustration right here because I couldn't find a diagram that sufficed. And so now all of you are subjected to my subpar art skills. My apologies. So we see 4 commits in the local repo, and we see none in GitHub. And with Git Push, it sees that GitHub has none of these commits, so it's going to copy all 4 of these commits into GitHub. So how do we get code? So like, yeah, this is basically the code snippet that I snatched from the other slide. We mentioned git push -u origin main, and basically this syncs the online remote repo with the repo on your device. And before this command runs, so like after the git branch -m main, the online repo has no commit in it, even though it was bound to your local repo. And pushing means that you're ready to share the changes you made in your personal repo with everyone else who's going to see and edit the code in the online repo. So you tell GitHub to copy the commits you just made in your personal repo to the online one. And so now the online repo has a commit that you made in your personal repo. It's kind of useless to only be able to push code to the remote repo. We also want to get code from the master version. So so we have this command, converse to Git push called Git pull. And what this does is it compares the repo on GitHub to your personal repo. And if the GitHub repo has something that your local repo does not have, it copies these changes to your local repo. And we see another of my hand-drawn illustrations at the bottom. We see that there are no commits in the local repo, but 4 commits in the GitHub repo. And when you call git pull, it notices this difference. And it because you have nothing in the local repo, it copies everything from GitHub into your local. So let's do another small demo. I'm going to create a GitHub repo on I'm going to create a GitHub repo online, and then I'm going to link my remote repo to the local repo. So here's GitHub. I'm going to create a new repo. We have no template. I'm just going to name it Git demo. Whatever you name your repository is what your project's going to be called. So choose wisely. And we're going to make it public so that everyone can see like your project, and so like it can be judged and everything. And you can like add collaborators, and you don't want to click add a readme, add a git ignore, and choose a license. If you want to add a readme or git ignore, you can add that later. I'm going to create this repository. And so I was saying, like, you'll know where the GitHub repo URL is. It's right here. You can just copy it right here. And in terminal, because we got to link everything to the remote now, you're inside of your project folder. And then you got to do git remote add origin. And then you just paste in that URL that you copied from GitHub. And so git branch -m main, git push -u origin main. Remember that these commands are the ones that I mentioned in the slides. And we can see now that that in GitHub, if you reload, you can see that we have the commit that I made on my local device on GitHub. Okay, and so incidentally, you can add collaborators to your GitHub repo by going to settings, collaborators. Oh, we gotta reconfirm access, and then you can just add people here with this button. You just add your teammates with their GitHub usernames, and then they'll get an email, and then they can just like join by email, and then when they join by email, they'll end up at this screen. And so your collaborators, you're gonna have to go to this code button right here. You can also get the URL right here. So you click this button and you copy this link. And if you go inside your terminal, you CD to the folder you want your project to be in. And then you just do Git Clone, and then the repo URL. And then you just hit enter, and then you have that repo on your device, and you can push and pull between that repo and the online one. So back to the slides. Let's talk about this more about this code segment that that I just ran to link the remote repo to the local one. I know you're kind of like, yeah, like just run these 3 commands. It's fine. Like I don't need to know much about them. Just I'll just do them. But I actually disagree, because I think it's very important to understand what these commands do, because they relate to some pretty important topics in Git. Specifically, let's start talking about this second one right here, Git branch. It's a whole topic in Git, and it relates to this image down here where we see 2 lines of snapshots / commits pointing to one singular commit. Like, what is this? We're gonna talk about this. So hold on to your socks, friends, because we're about to jump into an exciting topic called branching. So let's go back to the video game analogy, because it's been working so far, and if it ain't broke, you don't fix it. So we're playing a multiplayer game this time, and you want to speed run this game. So you want to get as much done in as little time as possible. And like this diagram down here, you're working as a group, and then you guys all split off to do your individual side quests, so that you can get everything done, and then in a shorter amount of time, instead of everyone going through the side quests together, like in serial. This is basically branching. You can do the same thing for your code, and because in your project you want different features. So rather than having everyone work on a singular feature all at one time, you can do division of labor and just have everyone take up one feature each. And like in the diagram, you guys have initial commits to set everything up, and then you all branch off to work on your separate features to get the project done in a timely manner. So let's talk about, let's break down this image that I had from 2 slides ago. Let's talk about the main branch. Every single repo has a main branch. And the main branch is the branch that everyone looks to see the finished product or the latest working version of the product. And we try to only commit to main when our code is impeccable and we know for certain that we want our code to exist in the final product. So i.e., the code that we commit to main should not be in its developmental stage. So what do we do with code that is in its developmental stage that we want to track? You put them in the feature branch right here. You see how it branches off main. Branches in general are isolated development spaces where you can track the evolution of your code that you want to add to the final product, but the code is still in the works. For example, say you're building a version of Instagram. The main branch would hold the final product that you're adding to as you add more finished features. And you add feature branches to work on features of Instagram, such as messaging, creating posts, comments, etc., because you're still working on those features. And while you want your progress tracked, you aren't ready to add what you have to the final product, i.e. you're not ready to add it to main. So let's go over some branching commands. So we have git branch. This command alone will list all the branches you have on your local repo. So say this is your local repository, and you run git branch. It would output main feature 1, which is the name of this branch, and feature 2, which is the name of this green branch down here. But sometimes you want to visit a branch that someone else has made and pushed to GitHub. So you're going to do git branch-r, and that lists all of the branches that have been pushed to GitHub by all collaborators. And what if you want to create a new branch? Then you can do git branch, and then you list a branch name, and that will just create that new branch with that branch name, but it will not push that to the repo. So you've created or listed your branches. How do you get onto them so that you can edit in them and not affect other branches with your development? You have to do git checkout and then branch name, and that the branch name you specify will tell Git to move you to that branch that has that name. And now you can feel free to develop and commit and revert changes to your heart's content without worrying about undoing someone else's change somewhere else on the repo. And all commits you make after checking out will be a part of this branch's snapshot history. So say you were on main and then you switched to feature 1. So you did git checkout feature 1. Now you're on feature 1's branch, and you can continue committing, and it'll add on to these purple circles down here, these purple commits. And say you want to create a new branch and like move on to that and like switch on to that new branch, you can do git checkout -b branch name. So that will create a new branch called branch name, and it'll switch you on to that branch. For newer versions of Git, there's git switch. Git switch branch name switches you onto the branch that you've listed, and git switch -c branch name creates a branch with the name you give it and switches you to that branch. It's basically a combination of git branch and git checkout. I will be using git branch and git checkout mainly because I haven't updated Git in a hot second, but you guys can use git switch. You can also push and pull branches to work with collaborators on your branch. So to push branches, you do git push -u origin, and then your remote repo branch name. And remember, we saw this command right here when we were linking our remote repo to the local one. And so basically what this does is, and so yeah, it just pushes your branch to remote, and I recommend every time you create a local branch, just like immediately do this. And like what this command specifically does is it created a local main branch. Well, it created a remote main branch and then pushed the commits we had on our local main to the remote main. And then so here we have to pull, we have git pull. So if you're already on the branch, then you can just do git pull. But if someone else created the branch, you can do git branch -r, which once again lists all the remote branches, and they will be listed as origin /branch name. So to get onto those branches, you have to do git checkout branch name, like without the origin /, and then you can git pull, git push as normal. So let's create a branch and push the branch to remote. So let's list all of our branches first, git branch. And we see that we only have main. So I'm gonna create a new branch called test branch. So I'm gonna do git checkout -b test branch. Remember that this creates the branch and switches me onto that branch. And so if I do git branch now, we see that there are two branches, main and test branch. And terminal will highlight and whichever branch you're on, it'll highlight and star it so that you know that you are on test branch, earlier when I did git branch, it showed that we were on main. So I'm going to push this branch to remote. I first want to check out, I first want to see which branches are in the remote repo. We see that we only have origin/main. So I'm going to do git push -u origin test branch. Once again, the branch name I list here is going to be what the branch name is for the remote repository. I definitely recommend keeping the same branch name between your local and remote repository just to eliminate confusion. So now if we do git branch -r, we see that there are two branches in the remote repo, main and the test branch that we just added. So you can also go to GitHub, like reload, hello. And if you go to this button right here, you can see which branches you have in GitHub, and you can see main and test branch. Test branch is the branch that we just made. Okay. Oh, shoot. Okay, so back to the slides. So in our video game analogy, you and your teammates went off to do all the side quests individually, and now you guys gotta come back together and bring all your progress together. So you gotta go from like all of your individual paths to like smushing them all into like one game, because individually you only have part of the game finished, but together you have completed the game. And basically the process of sharing your progress with everyone else is called merging. So in Git, oh yes, this is basically what I said earlier. Oopsie. So in Git, merging is when you unite two or more branches. We really only recommend merging 2 branches at a time, otherwise it gets very, very messy, very, very fast. So say you're creating a version of Instagram and you finish creating the post feature on your feature branch, and then you would want to merge in order to get your final version of the feature onto the main branch with the finished product that we have so far. And so basically, merging takes your finished feature and adds that functionality to whatever was in the last commit of main. So this is a very good image, I believe. So it's kind of just like smashing your feature branch into main once you're done with developing your feature on the feature branch. And I understand this is a little confusing, so I have this comic right here. It's kind of small, but you can see that this castle up here is a feature branch, and these grassland huts over here are main. And so once you finish development on your branch, you kind of just like smash everything from your branch into main, and then you end up with this lovely mishmash of both feature and main, like on the main branch. And so yeah, I think this is a good comic for explaining what merging kind of looks like as an end product, and it also kind of explains the imperialism, but like that's outside of the scope of this workshop, so we're not going to address it, but we definitely acknowledge it. Theoretically, merging is all fine and dandy. I'm not actually sure if anyone uses the word dandy anymore, but I just did. You're welcome. But in reality, things aren't always clear cut. So back to a video game analogy, 2 people ended up doing the same quest for reasons. And now you can't automatically merge everyone's progress together because 2 people's actions clash and might have ended up with different results. So you're going to be like overwriting like one person's contribution, and that's just bad voodoo. So in essence, this is a merge conflict, and to solve it, you got to figure out whose work you're going to take for the final version. Merge conflicts occur when trying to merge two branches that have different code in the same corresponding region, and don't worry, they rarely happen, but now you're going to be prepared to deal with them. Merge conflicts tend to look like this with like arrows, and then the word head. Head refers to the latest commit in the branch you're currently on. And there's going to be the code from your head commit, and then there's going to be a line of equal signs, and then more code from the branch that you're trying to merge in to your current branch. And in this case, this is the branch that we're trying to merge into our current branch is called new branch. So let's break down this merge conflict thing. What does this mean? This means that one commit in the branch that we're trying to merge in has not all cabbages are created equal in the same place that we're all in a yellow submarine in our current branch, and Git doesn't know which version to take. So to solve this, you gotta figure out, okay, which version of the code do you want, or can we integrate both people's work? And then to select the version of the code you want, you have to delete all of this, we have to delete the lines that I've colored purple. So this arrow, head, equal signs, arrow, new branch. And then you delete the version of the code that you do not want. So if you wanted not all cabbages are created equal, then you'd have to delete we're all in a yellow submarine. So here's the git command for merging, git merge branch name. So this will mash the latest commit from the branch you listed into the branch you're currently on. And you never want to be on main and call this command, because we only add commits to main that we're absolutely certain are impeccable, okay? So always merge main onto your feature branch. This way, if something breaks, you can address it on the feature branch. And it's just everything's safer that way. And so once you've resolved all bugs and merge conflicts, you can pop everything from your feature branch to main. So there's also git merge -- abort. This aborts the merge if you call git merge branch name and then you realize, hey, I didn't want to do that. So merging is tough, and I'm going to give you guys step-by-step instructions to merging. So one, you got to be on your feature branch, and two, you got to push to your remote branch using git push -u origin and then your remote branch name. Then you got to make a pull request on GitHub. So you do that by going to the online GitHub repo, and under the pull request tab, you'll see a notification that says, the branch you created has recent pushes. Would you like to compare in pull requests? Yes, indeed, you would like to. What's a pull request, you ask? It's a safe and easy way for us to merge. You'll see when you create the pull request that it'll either say you can merge automatically or you can't merge automatically. Here for this this pull request that I'm demoing, you can't merge automatically. So you're just gonna have to keep watching the slides to see what you do. But if you do see the text that says you can automatically merge, you just create a pull request, and then then there's gonna be another green button like, oh, merge this pull request, and you're just gonna click merge. But let's see what to do when you can't automatically merge, meaning you've got a merge conflict. So the PR will tell you. A PR is pull request. The PR will tell you where there is a merge conflict, if there is one. So like you see right here, the conflicted file is in philosophy.txt. So to fix this, on terminal, you gotta update your local main branch. So switch back to the main branch, and then you gotta pull to update it with git pull, and then switch back to your feature branch with git checkout, your branch name. And then merge main to your branch, git merge with git merge main. Fix the merge conflicts the way I showed you, like on the previous slides. And then once you've fixed the merge conflicts, then you can do git add dot and then git commit -m with your message. And then step 9 is you should push to remote branch. We've seen this command before. And then when you go back to your online GitHub repository, your PR should say that it's okay to merge. So just click merge pull request right there. So I'm going to demo merging for you guys, and I'm going to simulate how to deal with merge conflicts. So we're on terminal now, and I'm on the test branch, and I'm going to verified this with Git branch. Wait, oopsie, Git branch. Yeah, so we're on test branch. And I want to update our philosophy.txt because I don't know, we gotta like start collaborating on our code, right? So I personally think I know better than the person who created the commit on main. So I'm gonna say when a door closes, a window of opportunity opens. But we're all in a yellow submarine. Save that. And if you do git status now, we see that we've modified philosophy.txt. We're going to create a commit. So I'm going to do git add dot. So if we do git status now, we see that we've added philosophy.txt to the staging area. And then git commit -m update philosophy.txt. Please never just like do this kind of commit message. It's bad form. Please don't be like me. And then we're gonna do git push. Yeah, and then if we go to the online repo now, we see that we have a new commit update philosophy.txt. And then now we're gonna pretend like someone else just pushed a change to main. So git checkout main. And if we go back to the code, it says we're all in a yellow submarine because we've switched branches, right? And this person who committed to main just wrote, not all cabbages are created equal. There's a story behind this, guys, but just like let me know in person if you want me to tell you the story, but I'm not going to go over it in this workshop. And on terminal, if you do git status, we see that philosophy.txt has been modified. So I'm going to do git add dot to put everything in the staging area, git commit -m. The message is some philosophical thoughts. And then git push. All right, and if we go back to this GitHub repo and we go to main, we see that we have our new commit in here. So let's look. So we want to like merge everything now. So so do you see how this we had this yellow notification up here? Test branch had recent pushes 2 minutes ago. Compare and pull request. Yeah, we're gonna create a pull request. And it's update philosophy.txt. You can name your pull request. Like I recommend like naming it after the feature that you're trying to merge in. But I'm not gonna change it right now. We see that we have this red notification. You can't automatically merge. Don't worry, we can still create the pull request. So I'm gonna do that. And ooh, look at that. We got a conflicting file in philosophy.txt, and we gotta deal with that. Gotta deal with that merge conflict. So in terminal, I'm gonna do git checkout test branch and git merge main. Look at that. It says conflict content. There's a merge conflict in philosophy.txt. So we can't automatically merge. We got to fix the conflicts, then the result. So in VS Code, VS Code does something fancy that I think other IDEs, other text editors will do as well. We see that it's color coded. We see that this is the current change. Head is the current change. This is the branch that we're on. And then the incoming change is what is the change from the branch that we're trying to merge into our current branch. And we see like these buttons up here: accept current change, accept incoming change, accept both changes, compare changes. So accepting current change will just go through with the change that we have on our branch. Accepting incoming change will accept change from main. Accepting both changes means that you want to integrate the code, because like maybe you guys were editing in the same segment, but you guys have different functionalities and you just want to accept both. Or you want to compare changes for like a large code segment that's just like having a merge conflict and you want to see what changed specifically here. For us, I'm just going to say that clearly we want to accept our branch. When a door closes, a window of opportunity opens, but we're all in yellow submarine because clearly we're smarter than the hypothetical person who committed on main. So I'm going to do accept current change, and you can see that that deleted the lines that had like head, the equal sign, and then the incoming change, and all we have left is the line that we wanted. So we're going to save this again, and then we're going to go back to terminal, and then we're going to do git add git commit -m resolve merge conflict in philosophy.txt. Eventually I'll be able to spell philosophy correctly, guys. And so we see that we were able to resolve the merge conflict in philosophy.txt. Git is very nice in telling us this. So because we've solved the merge conflict, we can go back to our GitHub and reload. Oh wait, sorry guys, I got a push. Oopsie. Git push. Yeah, okay, there we go. So when you reload now, because you've pushed, you've updated what GitHub is looking at. So now we see that because there are no conflicts with the base branch, merging can be performed automatically. So we fixed all the merge conflicts in our branch. Now this merging pull request is going to merge. It's just going to quickly and easily merge everything that we fixed into main. So I'm going to do merge pull request and confirm merge. And look, pull request successfully merged and closed. So that means if I go to the code and we're in main right now, we see the commit that I just made in when we resolve the merge conflict on our feature branch, resolve merge conflict in philosophy.txt. If I go into philosophy.txt, we see the change that I wanted from our feature branch that we had trouble with when merging. When a door closes, a window of opportunity opens, but we're all in a yellow submarine. So we've fixed our merge conflict. Go us. Real fast, guys, I'm going to show you guys some helpful tidbits for Git and Bash. So first, let's talk about a .git ignore. I mentioned this earlier. And I was like, when we were creating the online repo, and I was like, you guys don't have to create this right now. If you want it, then you can create it later. Here, let's talk about it now. So .git ignore is a file in your home directory of your project that tells Git which files to never include in the commits. So the home directory means like directly in the project folder. And if you opened your project folder, the .git ignore file would be right there, not necessarily within further files. So the .git ignore literally has text in it telling the Git repo what files to not track. And it actually looks like this. So if you wanted Git to never put a particular file named ignore-me.txt in the repo, then you would literally list ignore-me.txt, and Git would just never put it in a commit, never put it in the repo. If you want Git to ignore all files with the suffix .log, you would do star.log. It's the same thing if you wanted Git to ignore all files that start with A, you could do A star, and then Git would never put any file that started with an A in a commit. This star is basically just like a placeholder, and it'll just match any file that like has text where the star is and matches like the characters that you specify. And then if you want Git to ignore a folder and everything inside, you do some underscore folder and then slash. And if you want to write a comment in a Git ignore, then you just put in a hashtag and then you write your comment behind that. Some more helpful Git tidbits, we have Git Stash. And so this temporarily shelves the changes you've made to your working directory and that have not been committed. And this allows you to switch branches and work on something else, and you can always come back later and unshelve those changes and start working on them again. Git Stash Apply is the command to unshelve the changes that you stashed with Git Stash. So say you were working on a branch and you haven't committed yet, but you want to switch to another branch. To do so, you would have to do Git Stash, then Git Checkout to your branch. When you come back to the branch that you're originally working on, you do Git Stash Apply to unshelve your changes, and then you can continue working on those. Git diff -- stage prints out the differences between your staged files and the latest commit. And this is especially useful if you've been away for a while and you don't remember what you've changed since your last commit. Git reset -- soft ahead ~1 reverts the state of your repo to the previous commit, like not the last one, the second to last one. In doing so, it reverts, and so basically, it tells the repo that like the latest commit is that second to last commit. But this command is very nice because just because the repo thinks that the second to last commit was the latest commit, it doesn't get rid of the changes you've made to the files in your working directory. And so if you do Git status, the changes you made since that second to last commit will show up in Git status. So one more Git command that you might find useful is Git blame, and you can list a file after that. And so for each line of that file, it will list the line's author, like who wrote that line, who inserted that line, the date they inputted the line, and the commit that the author added it in. And this is very useful if like a bug has been introduced, then you can Git blame on a file to like do some detective work. So some helpful tidbits on Bash Edition. These are basically the commands that I used today in the demo. I had cd, folder, or a path. And this basically changes your directory or the folder you're in to the folder you name. That is like inside of the folder that you're currently in, or you can change your directory to the path that you specify. And ls lists all the files that folders and files that you're in the folder you're currently in. And ls-a lists all files and folders in your current folder, including hidden files. In the notes of this slide on the slideshow, I have a few more commands like make mkdir, which makes a directory, makes a file. I have rm, which removes files, and mv, which either renames files or moves files if you want to look at them, but I think you guys can do it just from your desktop, so I wouldn't worry too much about them. But if you do want to use them, yeah, just call over any hack officer or mentor and we'll be happy to help. So that's it from me, guys. Here's a few resources you might find useful. There's a Git cheat sheet that I've linked that I've used so often when using Git. I've linked some useful bash commands. Note that these bash commands might be different for Windows users. So Windows users, you guys are gonna have to like search up your own like cheat sheet for like command prompt commands. And then it turns out that like mentors and ACM hack officers are also resources for you guys. So you guys can come and ask us for help because sometimes we know stuff. So anyway, thanks a million for listening, guys, and happy hacking.